Okay, we're going to start talking today about mass, volume, and density. Mass, volume, and density. So, mass, let's just do a quick review. Mass is the amount of matter or stuff in an object. We measure mass in grams. So, we're saying like how much matter is present in something. This is different than weight. So you guys, if you remember back when we started talking about when we did all the forces and I measured the weight of things, and we said how weight is different because it's how much gravity pulls on that object. Mass is basically a consistent property per object. So if you have that, remember we talked about if you're on Earth and you have a certain mass and a certain weight, and then if you go to the moon, your mass is going to stay the same, but your weight is going to be much less because the moon's gravity doesn't pull as hard on your molecules. So mass is just how much matter is in an object. We measure that in grams. So mass comes in there's four, but we'll just keep it at three states: solid, liquid, and gas. And a solid has all of its atoms packed really, really tightly together. And so those atoms are allowed to vibrate in place, but they don't move around at all, or they don't exchange places with one another. So everything stays where it belongs, and it can like wiggle in its position, but it's not allowed to get up and move around. A liquid, on the other hand, has a little bit more freedom to do that. So if you guys think about a liquid, if you spill a liquid, it's going to flow all over. And so liquids basically have a definite volume, but not a definite shape. So in other words, if we go back to the idea of a solid has a definite shape and a definite volume. So like my cell phone here, it has a definite shape. It is a rectangle. It's got a definite volume. I could take the length and the width and the height, just like in math class, and I could measure the volume of that object. A liquid, on the other hand, has a definite volume, but no definite shape. So that's why you have to use measuring cups to measure all of your liquid, right? You have to have something to hold it into. So liquids will take the shape of whatever container that they're put in. So like this, for example, this is my water bottle. My water bottle has a shape to it. But if I were to pour this water out into a different bottle, say this one, this liquid would now take up, or this water would take up the shape of this container instead. So liquids have a definite volume, but not a definite shape. Solids have a definite shape and a definite volume. The third state of matter is a gas. A gas has no definite shape and no definite volume. So gases are pretty much everywhere, right? Gases will take up the shape of whatever container they're in, but you can also compress gases, or you can allow gases to move freely. So you can change the volume of a gas. So all matter is anything that has mass and takes up space. So this idea of mass is telling us that mass can come in three states: a solid, a liquid, or a gas. Solid, definite size, definite shape. Liquid, definite volume, no definite shape. Gas, no definite volume, no definite shape. And so that's what mass is. So that's kind of our first little introduction into what kinds. So like working with density, this is the first variable that we look at when we start talking about things like density. So I'll take questions right now. All right, moving on. Volume is how much space an object takes up. We measure volume in two ways: in milliliters or in centimeters cubed. If the object or material in question is a liquid, we say it's in milliliters. If it's a solid, we say it's in centimeters cubed. So in other words, if you take a little 1 centimeter by 1 centimeter by 1 centimeter box, 1 centimeter by 1 centimeter by 1 centimeter. Yes, you made a little tiny box out of it. And then you poured just a little bit of water and filled that box up perfectly. And then you measured the volume of the water that filled up that little 1 centimeter by 1 centimeter box. That would be 1 milliliter, would be 1 centimeter cubed. A 1 centimeter by 1 centimeter by 1 centimeter cube has a volume of 1, length 1, width 1, height 1. 1 times 1 times 1 is 1. So that would be 1 centimeter cubed. And then if you were to fill that up with water, the amount of water that would fill up that little 1 centimeter cube box is the exact same as a milliliter. So when we're measuring densities can either be in milliliters if they're a liquid or if they're a gas. or they can be in centimeters cubed if they are a solid. So which one, between these two things right here, we have a kilogram of feathers and a kilogram of rocks. A kilogram of feathers and a kilogram of rocks. So which one has more mass, the kilogram of feathers or the kilogram of rocks? And which one has the greater volume? The kilogram of feathers or the kilogram of rocks? Which one's going to take up more space, the rocks or the feathers? Now, if you said they had the same mass, you're right. Look, it's 1 kilogram of feathers and 1 kilogram of rocks. The volume, though, you're going to have a lot more feathers taking up space to create 1 kilogram than you are to get a kilogram of rocks. 1 or 2 rocks will probably do the job to take up a kilogram of space, but you're going to need a lot more feathers to do the same thing. So it's kind of a trick question. So density, basically what this comes down to is that because we can change the mass of an object all the time. You know, if I had a mass of gold, and I knew that the material was gold, if I cut it in half, I would change the mass of my gold, right? So it's not necessarily a physical property because it's so changeable. Different masses can still be gold, right? So we use density instead because density is defined as mass per unit volume. So if you think about that same bar of gold, if you cut that bar of gold in half, you're reducing the mass by half, but you're also reducing the volume by half too. So that mass to volume ratio kind of comes down in the same ratio, in the same comparison value. So it's a measure of how tightly packed and how heavy the molecules are in an object, or how much mass the molecules have in an object. So density is the amount of matter per given space. It says amount of matter within a certain volume. Sometimes we say how heavy something is for its size. And oftentimes when we start talking about density, we make the mistake of saying, oh, density is not, this object's more dense because it's heavier. No. You can't just talk about mass. You can't say this object is more dense because it's bigger. No. You cannot do that, because then you're just talking about the volume. When you talk about density, you have to talk about both mass and volume. You have to talk about both mass and volume. That's important. So remember, we say the definition of density is how heavy something is for its size, not just how heavy something is, not just what the size of something is, how heavy it is for its size. There's a big difference. It's a subtle difference, but it's a big one. Okay, so let's take a look at this one. Which one is more dense? So this is people who are standing maybe on a playground or something like that. So which one is more dense? If these squares represent the same area, which square is more dense? Okay, and if you said that the square on the right is more dense, you're right, because there's more people. If each of these dots is a person, forgot to say that, there are more people in the same amount of space. This one only has 1, 2, 3, 4, 5 people in this space. This one has 4. This one has a lot. I'm not going to count. Okay, so let's take a look at the next one. Now, which one is more dense? It's a little trick question. If you said this one is more dense, you are correct, because both of these have the same number of people, right? But all of these people are crammed into a smaller area. Do you see how that works? So same number of people, 5 in each, right? But this one's in a much smaller area. So how do we find the density of an object? Well, basically, in order to find the density of an object, all you have to do is take the object's mass and divide it by its volume. So you have to find the mass of the object. This is a picture of using a triple beam balance. We use scales. We use just the electronic balances. If you want to find the volume of the object, you do length times width times height. Another way to do that is what we call the volume displacement method, and we might get the opportunity to do that a little bit this week. And then all you have to do is divide your mass by your volume. Now your units are going to be in grams per centimeter cubed. That's a typo. That should have an M there. I'll just fix that right now. So it should be in grams per centimeter cubed. So to find the density, you find the mass of the object, you find the volume of the object, and you divide. Density is mass divided by volume. Mass divided by volume. So I want you guys to try this right now. Get out your cell phone calculators. If the mass of an object is 35 grams and it takes up 7 centimeters cubed of space, calculate its density. Do that now. So let's see. Our givens, mass is 35. Volume is 7. Density is mass divided by volume. 35 divided by 7 is 5. So if you said 5, you are correct. So let's try a couple of these. Let's try one of these density problems. So you choose any one of these density problems. And after you choose one of those density problems, I want you to hold that answer, and we might actually divide you guys up and assign you one to work on, and then we're going to go over the answers in just a minute. Okay, so here are some of the ways to affect density. In other words, how can we change the density of an object? Well, first of all, if it's a particular material, if you change the density of that material, chances are you're actually changing the material itself. So let's not think that density is something that could actually be changed within an object. You can't make gold more dense. You can't make ice more dense. You can't make water more dense. But if we want to start thinking about how we can manipulate densities, in other words, how do we get a more dense object or a less dense object? This is how we do it. So we could increase the mass. That would increase the density. So in other words, if we keep the volume the same and increase the mass, that will increase the density. If we decrease the mass, we would decrease the density. So if we keep the volume the same, so this is all keeping volume the same, increasing the mass will increase the density, and decreasing the mass will increase the density. So if we look at this between container A and container B, which one has more density? And if you said B, you were correct. You could change the volume and keep the mass the same. So if you look at A, we have a much bigger space here. B, we have a much smaller space here. So if we have a larger space with the same amount of particles, we'll have a lower density. If we have a smaller space with the same amount of particles, we'll have a higher density. So which one is going to be less dense here, A or B? Which one is less dense? Less dense. Okay, if you said A, you were right. Okay, so what 2 ways could we potentially increase the density here? I want you guys to think about what that is. What 2 ways can we increase the density of this particular material? We'll call it M&M. If you said to keep the mass the same and decrease the volume, that's one way. Or if you said keep the same volume and increase the mass, that's the second way. So now this is going to be part of your homework. You guys, if you pour liquids together that don't mix and have different densities, they will form different layers. So think about your salad dressing. You pull Italian dressing out of the fridge. You always have to shake it up. And the reason why you have to shake it up is because oil and water don't mix. You've probably heard that as a phrase too. Although those 2 people are like oil and water. They don't mix. And so that means they don't get along. Things of different densities do not mix together. Liquids of different densities do not mix together. And so you'll get these layers. So the liquid with the highest density is going to be on the bottom, and the liquid with the lowest density is going to be on the top. Okay, so objects or substances with more density will sink below objects or substances with less density. Okay, so if you're thinking about your Italian dressing, which is more dense, water or oil? And I want you to make a prediction. And if you said oil is actually less dense than water. So when your salad dressing is all settled out, it's actually the oil that's at the top, not the water, which is why you want to mix it up, because otherwise you're just getting oil all over your salad and that's it. You can also float other materials in between. So this is a super ball. A super ball is a rubber bouncy ball that will actually float in between water and oil. So let's take, if you have 2 or more substances, the more dense substance will be on the bottom, the less dense substance will be on the top. So the density of 5 liquids are measured as follows. And I want you to rank order these liquids from most dense to least dense. Do that now. Do that now. Okay, so now imagine that the liquids on the right have the following densities. So these are all the densities of those liquids. And what I want you to do is match the colors to the correct density. So which color liquid goes with which density? All right, so to review, formula for density, mass divided by volume. If you pour together two liquids that have different densities, they're not going to mix. The liquid on the top is going to have the lowest density. The liquid on the bottom is going to have the highest. So that's going to do it for our lecture today. Nice job, you guys. Thanks for participating. And if you need to review this lecture, it will be posted to Schoology.